concluded, that topiramate is a promising treatment for alcohol dependence. Complete parts A through F. What does it mean for the experiment to be placebo-controlled? Again, placebo-controlled means that one group was taking the treatment, the other group was taking placebo. Their experiment will have a control group that takes a placebo, which is an innocuous medication such as a sugar tablet. This control group serves as baseline treatment that can be used to compare to the group that is actually taking the medication. The experiment will have a placebo group, which will study the group that is actually taking the medication. The experiment will have a placebo group that takes no medication. The experiment will have a control group that takes a placebo, which is a lesser dose. No. So the experiment again will have a control group that takes a placebo, which is nothing. And the control group serves as baseline treatment that can be used to compare to the group that is actually taking the medication. So this control group. Okay, that is correct. What does it mean for the experiment to be double-blind? As we know, double-blind means the doctor does not know which patient in the study takes placebo and which patient in the study does not take placebo but takes the medication. Only the subject knows. No. Both the subject and the researcher know which treatment. No. Only the researcher. No. Neither the subject nor the researcher knows which treatment the subject is receiving, placebo or the medication. Why do you think it is necessary for the experiment to be double-blind? For integrity of the results, for less bias. Let's see what they say. So that the subjects receiving the medication do not behave differently, okay, and so the individual monitoring the subjects does not treat those receiving medication differently from those receiving a placebo. It makes sense, but let's read the rest. The experiment is double-blind to ensure that any observed effect of the treatment is not due to some characteristic. The experiment is double-blind so that the individual monitoring the subjects can better distinguish. The experiment is double-blind so that the subjects receiving the medication know. Absolutely not. So it's double-blind so that the subjects receiving the medication do not behave differently, and so the individual monitoring the subjects does not treat those receiving medication differently from those receiving a placebo. What does it mean for the experiment to be randomized? We know that. Okay, it means that the subjects are randomly selected from all of the people in the area of the study. It means that the different dosage levels of medication are randomly assigned to individuals that are not taking the placebo. It means that the different dosage levels of the placebo are randomly assigned to individuals that are not taking the medication. It means that the subjects are randomly assigned to take either the topiramate or the placebo. Okay, so the experiment is randomized. It means that the subjects in the study are randomly assigned to take either topiramate or the placebo. And they definitely don't know. It could be not a blind experiment, that's possible, but they are randomly selected to be put in the control group of placebo or in the treatment group with topiramate. What is the population for which the study applies? Then always go back and reread. To determine such and such, such and such, diagnosed with alcohol dependence. This is our population. We identified such and such number of men and women diagnosed with alcohol dependence. This is our population from which we selected patients and then randomly assigned them to the two situations, placebo or topiramate, assuming I'm pronouncing that correctly. The population is 30, no. The population is all 18-65-year-olds with alcohol dependence. The population is 30, no. The population is all, no. No. The population is among these people with alcohol dependence. That's exactly what it is, right here. The sample of is 371 men and women aged such and such with alcohol dependence. Okay, and the total of 371 was split into 183 subjects and 188. 183 plus 188 should equal 371. So the population is all 18 to 65-year-olds with alcohol dependence. And the sample is indeed 371 men and women. What are the treatments? We have two treatments here. We have 300 milligrams of topiramate or placebo. No, we don't have 300. No. And a weekly compliance enhancement intervention. We have 300 milligrams of topiramate or placebo daily, and along with weekly compliance enhancement intervention. What is the response variable? So let's take a look. Results indicated reducing the percentage of heavy drinking days. So our target is not to cure these people, but to reduce. We're happy if we can reduce the percentage of heavy drinking days. That's our target. And it says results indicated that. So percentage of heavy drinking days. What is the response variable? For topiramate, we hope that it reduces, but the response variable is the percentage of heavy drinking days. It's not a test score, it's not amount of placebo consumed, it's not amount of medication consumed. No, our target is to record the percentage of heavy drinking days. Okay, so we can continue with this, but I'd like to jump to some calculations, and we'll come back. We'll come back to the rest. I don't mind at all. So, but I'd like to just jump to some calculations. Okay, something like this. And we'll come back and finish up everything if we can today. In a randomized controlled trial, insecticide-treated bed nets were tested as a way to reduce malaria. Okay. Among 340 infants, I have to write this down immediately. So that's our first step. When we read a problem, we write so the total 340. Okay. 18 developed malaria. Okay. So if this is N1, X1 is 18. Among 257, so 257 is our N2, a different sample, not using bed nets, fine. 25 developed malaria. Okay, so X2 equals 25. At this point, I know what I have in my hand at this point, right? I have P1 hat as X1 divided by N1, X1 divided by N1, so 18 divided by 340. What else I know before I even read the rest? I have this, P hat 2 as X2 divided by N2, which is 25 over 257. I know this without even reading the rest of the problem. So now let's continue. Use alpha 0.01, so alpha 0.01 level of significance to test the claim that the incidence of malaria is lower. This is the key, right? Lower for infants using bed nets. Okay? So which one was using bed nets? So the first one, first sample. lower. So P1 hat lower, or P1 lower than P2. So the null hypothesis, P1 lower than P2. P1, they're using BetNets. P2, they're not. So, of course, P1 equals P2. I jumped ahead. This is the alternative, the claim. So the claim is that P1 is less than P2, which we know it's a one-tailed test. And it's a lower tail test or left tail test, right? And alpha is 0.01. So we can already graph. So we will determine a z statistic, and I'll show you in a minute how. We know that 0.01 is here. So this is our alpha. And if the test statistic is here, we fail to reject the null hypothesis. If the test statistic falls here, we have to reject the null hypothesis. If it falls here, this is p-value, huge in comparison to alpha. We fail to reject. If the test statistic falls here, then this will be p-value, which is smaller than alpha. We reject the null hypothesis. So back to the problem. So can anyone tell us what we are going to select here? Any? Very good. Indeed. That's B. Identify the test statistic. The test statistic is here already, but I want to show you how to determine that. They are giving us in this example. So with stats and tests, this time we're going to go to two proportions. Two proportions means populations, two populations proportions. Two proportions z test. So this is number 6. We are going to enter x1, which we have 18. Going to enter n1, which we have 340. x2, 25. n2, 257. And we do want this option, option 2. And you know that I always like to see the draw only because I will also see the shaded area for the p-value, which I like. But that's me. You can just use calculate. It's up to you. So I'm going to press enter. I see the p-value right here. Okay. It's bigger than 0.01. The calculator doesn't know what alpha we have, right? The calculator is just giving us the calculations, right? It doesn't tell us anything, any comparison. So I'll write the z equals negative 2.0747, and the p-value is 0.019. So coming back to our graph, so this is alpha, the 0.01, but since it's more than 0.01, it means that the test statistic is here, and the p-value is this. This is the test statistic, which is this value, z statistic. Sorry. What do we conclude? Since we see that this is greater than alpha 0.01, what would be our conclusion? We reject or fail to reject?
Fail to reject.
Of course. The null hypothesis, because z fell between these 2 points, which is the non-rejection region. If it had fallen here inside the rejection region, then the p-value would have been smaller than 0.01, and we would have had to reject the null hypothesis. Very good. Where am I? Okay, so identify the test statistic. They got the same thing as we did, negative 2.07. Because I put the 0, the point in the wrong spot. Is that correct now? Yes, it is. Good. The p-value, yes, at 3 decimal places, we got 0.019. And here it is, exactly the same thing they got. And what is the conclusion? The p-value, you already told me, is greater than the significance level alpha, so we fail to reject the null hypothesis. There is insufficient evidence to support the claim that the incidence of malaria is lower for infants using bed nets. And according to this, the bed nets do not appear to be effective. We failed to reject. So failing to reject means that the two proportions, so we failed to reject the null hypothesis, so it makes no difference. Bed nets or not, they're not useful. They're not effective. Okay. Who would like to start this one? Anyone?
This is D.
Thank you. Thank you. Thank you, V. I think you're muted.
Yes.
I think you're muted. Did you want to speak or not?
Yeah, I said that. Is it D for the question A? Or do you want me to read?
Yeah, let's read the question and then we'll discuss it.
Yes. Yes. Okay. Conduct the following tests at the alpha 0.001 level of
Yep.
significance by determining A, the new and alternative hypothesis, B, the test statistic,
And then the
C,
p-value. Very
the p-value.
good. So this is a key, very important. Remember that the samples are independent using simple random sample. So it says test whether P1 does not equal P2. And we have the sample data, X1, N1, X2, N2. Anyone else would like to tell us which are we going to use, which null and alternative? And what type of test is it? Anyone would like to give us an idea? It's okay if you're wrong.
Repeat the question, please.
Yes, yes. So it says determine the null and the alternative. And we are testing this up here. So we have to choose among A, B, C, and D.